You've likely seen SpaceX rocket boosters landing, and you were probably very impressed. This video might not have the same effect. So the goal is to create a simulation that tries to replicate boosters landing in a 2D domain. I'll create a population of neural networks that will try and figure out what their purpose in life is, which hopefully ends with them landing on the platform. Now that I've got a system with basic gravity and rocket thrusters, I need to create the population of thinking rockets. Although at the moment they're not really thinking at all they're doing is falling to their death. Next I need to create the neural evolution algorithm, which is basically just a mashup of neural networks and a genetic algorithm. So the rockets that do the best, i.e. the ones that are closest to landing, are more likely to pass on their genetic material to the next generation. So theoretically, the rockets should get closer to landing as the generations go by. Now I need to make the rockets think. So each rocket is going to be making a decision 60 times per second, which is just equivalent to the frame rate of the simulation. So given some inputs, the neural network will spit out some outputs, which will alter the behavior of our rocket. So looking at this image, you can kind of get a good idea of what I'm blabbering on about. The inputs that get fed into the neural network are the X, Y, thruster, and XY velocity of the ship. Also the distance to the goal, which is the platform. I'll be using 10 hidden nodes and 2 output nodes. The 2 output nodes will decide whether to turn on the thrusters to make the ship move in the direction it's facing, and or the rotational thrusters to make the ship rotate. The fitness value is what we use to determine whether the neural network gets to reproduce. This will be calculated based on a number of metrics, including the velocity, the angle, and the distance to the platform. So basically, the higher that value, the more likely that neural network is to reproduce. Let's put what we have into action and placing the rockets just directly above the platform to see if it can land and figure out that it doesn't require any rotational thrusters. So that wasn't completely awful. It sussed it by around generation 110, so let's make it a little bit more challenging. For the next experiment, I'm going to spawn the rockets on their sides to see if the angle thrusters kick in to make the rocket face the right way and land via its bottom. That time the little buggers figured it out in 290 generations, which is quite a long time when you think about it, but I am only using a population size of 20, so there's not a ton of variation each generation. For the next experiment, I'm going to spawn the rockets at a different X position to the platform, so they'll have to use their thrusters to get into the correct position as well as decreasing their X velocity in order to form a successful land. "854 generations later, it kind of figured it out where it's sort of not completely straight, so it exposed some dodgy code I'd written which allowed for rockets to land when they're not at a perfect right angle to the platform. So at the moment we have thrusters placed at the bottom of the rocket which allow for rotation. I want to add some more thrusters that will be placed in the middle of the rocket to allow for perpendicular movement, which should mean aligning with the platform should be a little bit easier. So a third output will be added to the neural networks to control this. Using our new thrusters, let's repeat the same experiment and see if it can land quicker. There's me thinking it would take 10 generations to figure it out. I was only 990 shy. Next I want to test with the platform moving to see if the rocket can match its x velocity to the platform's x velocity. For this test I actually upped the population size, which with that extra variation in there just managed to work it out a lot faster than the other scenarios. For the final experiment I'm going to add some savage wind and see if the rocket can use its thrusters to slow itself down to make a land. And that's pretty much it for this video. There's so many more experiments I can do that I'll probably do for my blog at codeair.com. If you enjoyed the video, hit subscribe. You might be my 8th subscriber, which would be wicked. Let me know if you liked the video or thought it was shite. Cheers.